Get started. Thank you everybody for being here. We're small but a nice crowd. So allow me to introduce myself. Everybody's here for the Google, right? Google Cloud. James Thorin is with me. He's also on the Google team. I'm Ricardo Payan. I'm basically we're thanks James. We're really close to here. We're on UP35. We have 3 offices here in Austin, and there is kind of the Google Cloud team based on 935, like 35th Street, kind of the UT campus. And anyways, I just want to we're a small crowd, so why don't we get a little bit to meet each other. So I'm new to Austin. Actually, I'm from Colombia, South America. I was there throughout my life. At Google, I've been 4 years. I've been traveling a lot. And I'm new to Austin, loving it so far, 3 months here, and bringing a lot of companies, a lot of startups in the cloud team. I'm also part of the 20% project. Has anybody heard about Google for Entrepreneurs before? Like that project, Google for Entrepreneurs? No, we're gonna talk a little bit about it. So I lead that 20% project within Google. So we at Google have a 20% project that we can lead aside of your core kind of role. And anyway, that's kind of what I am. I mean, we're really small, like around 10, and we have an hour or so. I mean, is it okay if maybe we can introduce yourselves? Yeah, just name and where you're from, and what do you want to take from today?
I'm Peter. I've been hosting websites since like the 90s. I'm from Florida originally.
Excellent, thank you.
I'm Tom. We have a startup in town where we're basically invented or created a technology that makes reading a virtual reality experience. So as we scale, certainly we use a lot of your tools. I'm here to learn.
Excellent, man. We have a meeting tomorrow, like a session. If you don't miss it, it's on virtual reality at 4 p.m. too. We're gonna have a Googler to explain about cardboard and stuff.
Okay. Here?
Yeah, it's gonna be in this, I don't know, this room, but you're in Capital Factory.
Okay.
I'm Jad. I'm just here for the talk.
Cool. Don't worry, we don't want to. It's okay.
I'm Justin. Really just kind of here to learn more about kind of what the capabilities are and kind of compare kind of the Amazon Web Services. I do sales and business development for startups, have for the last 8-9 years. But yeah, really just here to learn.
Excellent, man.
Hi, I'm Lisa. Same, just here to learn. It works with my schedule today to show this one.
Thank you.
Yeah, Manny from San Antonio, developer, and I just wanted to get some information from you.
Thank you.
I'm Prasad Jaladi. I run a startup called Intelligent Enterprise Solutions. We are promoting affordable innovation through intelligence analytics that cuts through patent, product, market, and business.
Okay, thank you.
I'm Shiva. I'm doing a health knowledge startup, and I'm trying to learn something about image analysis to track wellness.
Okay,
So I
excellent.
want to know more about Google Analysis, image analysis too.
Analytics, okay.
Hi, I'm Jeff Hoppy. I'm a native Texan, but I grew up in San Antonio, so that's kind of close to South America.
Closer than.
Yeah.
No.
I just finished a contract with one of your competitors, so thought I'd take the opportunity to learn about Google Cloud.
Excellent, thank you.
Thank you.
My name's Chris. I'm here to kind of learn about what companies or startups are using the cloud platform to learn more about what they're doing.
Excellent, thank you.
Tim, I have a company called Startup Learning Solutions. My actual target customer are startups, and trying to help them disseminate information and meet their training needs.
James Thorne, SE, work with Ricardo. If you'll have any questions about anything we talked about or anything else that we don't cover, feel free to ask us. Happy to talk.
Thanks, James.
Okay.
And I think that's, sorry to put you on the spot, but I think that's the idea. I mean, when we got invited to just even talk about Google Cloud, I mean, it's so broad that we can talk about anything. We talk about machine learning, we talk about gaming, we can talk about, and actually last week we had a lot of announcements. I'm gonna go through those in case that you have missed them. But yeah, I mean, just knowing where you are, what are you really interested is gonna make me focus a little bit more the talk. So, yeah.
I'm with him. He's wanted to compare to
AWS?
AWS.
Yeah, cool.
Yeah, I wanted to know how your
Excellent.
cost is
I agree.
compared.
Okay.
So,
And I think that's good. I mean, we have kind of a good mix, like technical, a lot of developers, but it's also like just seeing what's different. So I think we're gonna cover it. For today, I have this kind of agenda set up. This program. So I didn't hear. So yes, actually I did. Some of you are in startups. I mean, that's the essence of Capital Factory. So that I wanted to start through this. Who of you today know that we have this Google Cloud for Startups program? Other you 2, 3. Okay. Yes, we do. I'm gonna walk you through this program a little bit at least. But if you have more questions, again with James, we can then start answering them. This is very important to the people that are kind of asking themselves why is it different compared to Amazon, compared to Azure, compared to anything out there. I'm gonna talk a little bit, and I think more important, like how to build what's next. Actually, it's a GCP overview. I mean, what are the tools on the GCP toolset? When we started with GCP, Google Cloud Platform, actually it was just App Engine. Like it was platform as a service. A lot of big things got out of them. Snapchat is the biggest, or Snap Incorporated now. It's our largest customer. But obviously this has evolved a lot. So yes, we're gonna talk a little bit about big data analytics. We're gonna talk about machine learning. So there's there. And finally, we had a big event last week in San Francisco, and we did some announcements. So I just want to share that with you. We have an hour and a half. I don't expect to talk through an hour and a half. I'm gonna be tired by then. So again, if you have any question, please raise your hand and let's keep like conversation. The first point that's really important, relevant here, we all know what Google is. It's a verb. Yes, I don't want to go through that path. What I really want to highlight here is that Google Cloud Platform, as a platform, just joined the 1 billion user club within Google. What does that mean? Today we have 1 billion users active within Gmail, for example. So over 1,000 million people go into the Gmail account and look into the email, send emails. The same is true for any other of those products. So a nice analogy I like to use is, today more Android devices are being activated throughout the world than babies are born in the world. So that's the Google scale, and again, that's a billion. And when we talk about Google Cloud Platform, I'm not talking about 1 billion developers, obviously, but I'm talking about Google 1 billion users that are using at the same time the products on top of GCP. Pokemon Go had a lot to do with this. I'm going to talk to you a little bit about this. So what really, and this is part of the announcement last week. When I joined Google, we were Google Enterprise. Maybe not appealing for those of you in startups. I'm not an enterprise. Then, because of that, we changed our name. It was Google for Work. Not appealing again. And last week, we just changed our name again. So right now, we're Google Cloud as a division within Google. Not as a product. As a product or as a portfolio or solution, we are still Google Cloud Platform. But as a division, the highest growing division within Google, it's Google Cloud. Now, previously Google for Work. And this division, this area within Google has this kind of different areas. So Google Apps for Work, now it's called G Suite. These are different tools. I don't want to go through this path. Google Maps, Google Chrome, etc. Today we're gonna really focus on Google Cloud Platform. The way we see it is, it's just we are earning the hearts and minds of developers, building what's next, and that might sound like a catchy marketing phrase, but it really means something for what we're trying to do. But really, when we start thinking about what Google means for startups, it's not only about having credits on Google Cloud Platform. It's really this kind of ecosystem around the whole process. Google is the company like digital king, if you will. So you also want to be there, well positioned on the Play Store. You also want to be well positioned on the web search. You also want to have a strategy around YouTube, and obviously around the whole monetization process. Because at the end of that's what you want to do, money. If you're thinking like a startup, like a more consumer kind of application. So here, this is what we're seeing. I mean, we have this kind of three-piece strategy where we have apps, where we have cloud, where we have devices, allowing the startups to really thrive in short time. And we really believe on this startup ecosystem. That's why we have a Google for Entrepreneur system or program within Google. Google for Entrepreneur is basically we have partner with tech hubs around the world. In Austin, we have partnered with Capital Factory. So you told me about Florida. We're working something in Florida, but we have different tech hubs around the world. Detroit, we have one. Chicago, we have 1871. So different tech hubs are there, and that's the way for us to scale, and that's the way for you to get access to some of these Google perks. So some of the things I'm going to talk today, I think that the best way to enter into this is just entering into a trial. Who here has done this trial before? Who Who has tried Google tools before? Okay, yeah. A couple of you, nice. So first thing first, every Google product or every Google product has a free tier. So what does that mean? In the case of BigQuery, I'm going to talk about BigQuery. So BigQuery is, if you're starting to query below a terabyte of information, those queries are free. So that's kind of the free tier. The same applies for App Engine, the same applies for Google Compute Engine, so for different products. If you want to go over that limit, you always have a $300 free trial for anybody. You just have to put your credit card into that, and you're going to be applying. I mean, you're going to be start spending this trial. This is going to be through 60 days valid. So a piece of advice here when I get asked about, okay, how should I use this? I'm going to talk to you about the other program, like more larger scale. You should start using this trial at the beginning when you start like doing tests and stuff, not on production phase. Or I think the advice is not use the credits for the startup program. I'm going to show you this later. When you're like in the first weeks into development, because you're not gonna use it. So within this Google for Entrepreneurs program, we have grandfathered this, not grandfathered, but it's actually included, and it's a way for you, and I'm talking to you that if you're thinking, okay, I'm gonna go big next year. I'm gonna go and have 1,000 users and 10,000 users and 1 million users. Why not? You do have access to this program. I'm sorry, it might be small, the letters, but I'm gonna walk you through. So if you're in Capital Factory or if you are in one of the approved VCs, tech hubs that work with Google, you can get access to GCP and Firebase credits. So on this moment, the value is around $20,000 for a year. So you can have $20,000 in credits worth of GCP. The second point is very important. You have access to office hours from Google experts, engineers. So, and that's very easy to scale. So you just go through an application, you just click, I want to talk with an SE or a Google engineer in networking next Friday, and I have this architecture, I have this problem, I don't know how to scale, I don't know how to connect with a on-premise technology. You could just go and schedule this office hours. Support, that's very important too, and actually that's one of the highest praise points for Google, its level of support, because again, it's a completely different paradigm, like from companies that moving from on-premise world, moving to the cloud, support is really critical, and you have access to gold support 24/7 with an SLA is very strict, so like depending on the priority case, on the level, you can have even to 1 hour SLA response time. And you also have access to Google Apps for a year, free of Google Apps up to 10 accounts, that usually helps, and online training.
Just to be critical of this, I mean, for $10 hosting account with like Linode, I can get 24/7 support.
Yeah.
So why would I do this when I could just spend $10?
This is free, and again, the support, you're only getting the one part. You're also getting like 20,000 on.
I know it's free, but free and $10.
So don't think of it like support as my VM is broken, help me.
Yeah,
It's
that's
architectural support as well.
Okay.
So here's my architecture, here's what I'm trying to build, I'm having trouble with this piece, can you help me?
Okay.
So.
And that's a great point. It's not like, yes, I'm just not troubleshooting. I've been in support calls with customers like saying, okay, I'm scanning petabyte, and it used to work before, and now it's not working. But that's kind of like just the tip of the iceberg. But it's like, okay, I want to go to the next petabyte on BigQuery. So on that case, we have support. It's not only like, yes, the support on the fixing it, but on the architecture. Yeah. But thanks. Yeah, it's a valid point. And then you have access to online training. Today we're just going to scratch, like I want to give you an overview of what really GCP is, and my goal for you today, for me today, is that you go out and say, okay, I really want to deep dive into App Engine, or my use case is more into VMs, and I have thousands of VMs, and I want to use Hadoop on the cloud. So those kind of things. There's a specifics online training for this. We have trainings on site, delivered on site, on also online around it. So again, I really want to start from here. There's some eligibility kind of criteria, but I want to start from here because, to be quite honest, this is something that a lot of people don't know that exists. A lot of big companies started through this, and now are great and big startups. So this is definitely a good point. Some companies, I have to be completely blunt, by you accepting this and by you enrolling to this program, it doesn't mean that you can't work with any other cloud vendor. A lot of startups are adopting strategies multi-cloud. startups and companies, enterprises. Okay, so I go with Google for this workloads, but I'm also testing this workloads for Amazon or for Azure, for any other cloud vendor out there. So that's also important for you to know. It's not like restrictive kind of, this is your program and you have to be completely loyal to Google. That's not the case. So anyway, again, this is free, so just want for you to know it's here. From the use case perspective, some of the things we're seeing, and this is not by any means the only use cases. We're seeing so many different use cases. Every customer that goes out and tells their story is completely different and has a very specific. But when we try just to kind of box them into our 4 main use cases, we're seeing this. The one is analytics and big data. Google's known because of the scale of Google. Because okay, what's big data for you? For Google, very a different scale or larger scale. And again, this has to do with the fact that I just saw you the services that we have 1 billion users. So just for you to have an idea, all the connections from this 1 billion users, we're storing them, we're analyzing them, we're doing 0-day threat detection on that. So we know what big data is, and that's an interesting talk. I'm going to talk a little bit about this later. So yeah, any kind of analytics, big data kind of play is getting into this workloads. We have, I don't want to jump ahead, but we have companies that just have invested a lot into their Hadoop ecosystem. I mean, you can take it to the VM on Google and just spin it up and start working. But we're working more on fully managed services within Google. So BigQuery is their enterprise data warehouse on the cloud. And also our on distribution, no managed or fully managed of Hadoop Spark ecosystem within Google. So that's the first one. The second one is low, and this is kind of low value, if you ask me, but it's still very, I mean, it's very used. It's just storing. I mean, storing is the cheapest and dirtiest thing out there. So why not putting on the cloud? Why still suffer with tapes? Why still suffering with all this data archival strategies? And the third one is really one we're seeing pick up a lot, is test development environments. And when we talk about startups, is obviously about speed. I mean, I want to be agile. I don't want to wait for a week to have my next build. I can have tens of builds on the same day. So on those kind of environments, Google and any cloud environment, but really Google has some differences there. I'm going to talk about this. And we've been publishing a lot of solutions, a lot of articles, a lot of tutorials around how to do it. So we have Jenkins, like proven on top of this. We have Chef, Puppet, any kind of this CI/CD tools are completely integrated with this. And it's not, I mean, that's kind of like normal within any cloud environment, but we're using this and we're pushing this a lot within our customers. And finally, high value compute intensive workloads. We're talking about tens of thousands of nodes of VMs, like cores, just processing a lot of information. And I'm going to tell you why this is different in Google and why a lot of customers use this. So actually I'm going to start by this. Yeah, the size of the font is very bad here. But Descartes Labs, this is one of our customers. I work very close to them. They were a startup. Actually, they were based out of Los Alamos National Lab. So these guys were a lot into satellite image analysis. So what they do today, their current business model is they have a lot of information, a lot of data around images, basically satellite images, and they correlate it with a lot of hard data on production, crop production. And what they do is they have a lot of images, like hourly images even from different crops. So the business case is the following, or the problem is, we have a lot of information about crop production in the US, and that's it, and maybe in the developed world. But what happens on the rest of the world? Africa, South America, even China. I mean, what happens with that? And depending on this, if the production is going to be low, it's a commodity. So if the production of rice is going to be higher this year in China, it's going to be obviously going to change the whole price on that commodity for the rest of the world. So basically what these guys are doing, they're applying a big data machine learning algorithm or model within Google. And they are crunching a lot of data with Google. They have preemptible VMs. I'm going to talk a little bit about this. But basically what they do is they don't care that they have set up their architecture in a way that they don't care that the VM is killed in a specific period of time. I mean, they can be killed, the VMs, within 24 hours. But they have set up their architecture in a way that even if it's killed, the state is persistent. So they're going to have savings of over 70% just by doing this. And at the end, they're going to still have the same compute power of Google. So they're crunching this. They're having a very successful business model. And again, this is just the first step. on having this kind of crop production business model or business use case, but they're doing a lot of more stuff with this. They have a very good success story here. Yep.
With Compute Engine, can you pick where your server is, like geographically?
Yeah, you can pick zones. You can pick the region, and within the region you can pick the zone. And we're investing a lot. I have actually one slide about where, because we were behind on that. We used to have 3-4 regions. Now we're investing in over 10. But yes, you can have data location where your
So you're
zone
going
is.
to show a map of that?
Yeah.
Okay.
Okay, so now I'm gonna get a little bit more into the product side. Before that, like what really makes Google different? Google is basically a cloud-born company. Even from day one, when Sergey Brin and Larry Page started thinking about this, let's index the web, let's index internet. It was really internet. I mean, it was cloud from day one. So we're not retrofitting a lot of client-server architectures, a lot of on-premise architectures. For more than 15 years, we've been doing this. And it's not only about thinking about it, but it's also about distributed systems. So a lot of things that today are about cloud were born in Google. So think about Hadoop. Hadoop is today a thriving open source ecosystem for big data. But really the origins of this was because of big data. About Google MapReduce white paper. When we published this, it was a way for Google. The MapReduce and the Google file system, it was a way for Google to solve a problem about distributed file systems. I mean, we have all this information, we're indexing trillions of pages. How do we do this on a scale, on an internet, planet-based computer scale? So, because of this, Google has been investing a lot in this. I'm going to share with you how much we've been investing, but it's only last year we've invested over $10 billion. 9.9 billions on CapEx, which is a lot of money. Into networks, into broadband, into our own networking. So our networking, and that's another interesting point, is completely software-defined network, SDN, built from the ground. It's built on Andromeda. It was our own kind of internal implementation. We put it out there, we published the white paper, and it's something that we've been completely working and improving constantly. So this is what I was telling you. We've been opening a lot of data centers. We've been laying thousands and thousands of miles worth of bandwidth of fiber within oceans. So Google runs within their data centers. All the connections are Google-owned cable, our own fiber. We don't have. I mean, we do have several connections and on POP. I'm gonna talk a little bit about this later. All the fiber is Google owned and Google maintained. So that also has some implications on the security side. And again, I want to do this like a sales pitch, but just for you to know how much are we growing, how much are we really investing into this. Just some figures. I talk about App Engine. It was our only offering on the cloud world. This is the size that we're growing every 3 months. Every quarter, storage is growing by 10. Compute is growing by 4 on the Compute Engine side, and really what's growing like crazy right now is containers. So containers on the Docker, Kubernetes, this kind of infrastructure is crazy. It's growing by 15x today. So when we think about really what a Google Cloud is today, what really is Google Cloud, and how did it born? It was really what we like to think about this first wave. It was really colocation. So I want to save my own hosting. I want to save my own physical space. I want to save energy, AC, networking. So this is how cloud started for most of the companies. And a lot of companies say, you know what, I have cloud strategy, I have a cloud project because I now have colocation. So that was the first wave. Obviously this has a lot of problems. I mean, they still have a lot of burden for the companies, for the developers. Then came the virtualized data centers. So once the VM concept picked up, now why should I run my VM? It's all about utilization. Why should I run my VM still in my data center? So I just push it up to the cloud, and then I have my virtualized data center. This is what today really is cloud about. And if you go to any kind of vendor, it's like, yes, I can have your VM on the cloud. And that's basically, I mean, yes, we're having a lot of managed services, but that's it. what we really want to know and what we really want to push for on the Google side about the Google Cloud, and this is what we are really thinking different, is it's not only about having VMs, it's not only about having cost reduction, about cost efficiency, it's about having elastic services, it's about having managed services where developers don't have to worry about anything about infrastructure, but really about development, where companies can be very fast about launching new products and services, and when really new features about the underlying infrastructure can be incorporated into the company or startup infrastructure without anything being done. So this really resonates with the DevOps kind of concept, if you will. So this has been noticed by some analysts. And again, this is maybe too salesy, but yeah, I mean, Gartner, even though, and I have to be completely blunt, I mean, yes, a lot of people, a lot of companies, when I go out and talk with them, is like, okay, you're kind of waking up, because Amazon has picked up, I mean, for so many years now. Yes, I mean, yes, we're waking up on not on a product perspective, but on a sales perspective. I mean, we have the product, and that's something that we did. I mean, we acquired a company. It was called Bebop, and one of the benefits of that acquisition is that we were able to onboard Diane Green. I don't know if anybody heard about her. She was one of the founders of VMware, and she and the rest of the team, I mean, they have been investing a lot into this new era of Google Cloud. And this is something I can share because it was public. Urs Hosel, our CIO for some time, CTO, the SVP of infrastructure, said at some point that, like it was last year, right? Actually, it was this year, last half. He said that the goal is that the Google Cloud business can outperform the Google Ad business, like the advertising business. It's pretty aggressive, if you will, but I mean that's the goal. So anyway, the analysts are picking up on this. Gartner just said this. I mean, yes, it's not only about having infrastructure, not only about having fiber, but really how the development teams, operations teams can run faster with Google Cloud Platform. So from a layer perspective, this has a lot of text, so I'm going to run a little bit faster on this. But we basically have 3 layers. So infrastructure and operations. We're going to talk about GCE. We're going to talk about Stackdriver, about how to monitor this cloud. On the data analytics products, Google Cloud Storage is one of this. Actually, this is not the best slide, so I'm gonna move forward. And I want to start answering some questions, like implicit questions that you have. How is Google Cloud Platform different? And this is one kind of like our 5 layers or 5 themes that we really differentiate. One is security. Again, going back to the theme of 1 billion users, Google Cloud or Google as a service can't be, I mean, we can't afford to have an anonymous hacker mask on our front page. That's something for real. I mean, imagine that happens. And I think that's the same problem with any internet company out there. But Google invests a lot in this. So Google has one of the brightest, some of the brightest minds I have met within Google and the world are the security team. These are not only Google security expert, but industry security expert. These are teams that are PhD, that are consistently contributing to the academy, to the open source world, publishing a lot of white papers around security. So definitely is part of our DNA. We have been investing a lot into strengthening the encryption story. So just for you to know, right now customers can bring their own encryption keys. That's something that we didn't have before. And encrypt their own disks, encrypt their own data within Google Cloud Storage and within Google Compute Engine. So that's something that we now have. Obviously, we also encrypt it at rest, but in case that you have a use case where you want to manage your own encryption process, your own key management process, that's something also that we can do. And from the networking perspective, security is very hardened. So we do a lot of things over there. I mean, just because of the sake of time, I'm not going to go deep dive, but we do a lot of things there. From the network perspective, let me jump to this. Sorry, no, I was too far away. But actually, let me do this because I know you were asking about the map. So let me show this. So Google has been investing a lot in this cloud, and this is the map that I was telling you that we have. This was a recent announcement. This happened last week. So before this, we have 5 regions. So Tokyo in Japan, we have Singapore, we have Oregon, Iowa. So we have 3 regions on US. We have 1 in Europe, and we have 1 in Asia. So we have 5 regions. Right now we're going live with two extra regions. Actually, all East, US West is one of them, and Tokyo is the other one. But we are committed to bring new regions for next year. So in case that if your startup or your company is more like on a global kind of how do I deliver? How do I spin up these instances within a global network? We have been announcing this from last week. But more than this physical kind of distribution of data centers and point of presences, what really drives our network is, again, it's a software-defined network. And what we really want to have is low latency for the users. So what really happens, without getting too technical, is we want to offload any Google traffic as close as possible to the user than we can. So we have a lot of points of presence. We have over 100 right now. And once that we have it on our network, it's going to go over a Google Fiber network. So what we really want to do here, because it's software-defined network, is to decrease the number of hops of all the packets that go through your application or with your application through Google Cloud, and obviously decrease the latency of the user getting to the data. So that's kind of the high level of what we do. How we do it, we have a lot of research in this. So we have Andromeda as our first software-defined network, and we've been improving this a lot as we move forward. So let me get back to this.
I got a question.
Yeah, sure.
What's the fastest growing area that you could tell startups you should go after that market, maybe because it's growing and use our product?
Yeah, I honestly don't know from a startup perspective. I know that generally speaking, containers is growing a lot. So Google Container Engine, basically Google Container Engine is an implementation of Kubernetes. It's one of the products that's growing the most. I can tell you kind of anecdotally, when I talk with startups, a lot of machine learning is there. There's still a misunderstanding about what machine learning really is. So a lot of people talk about machine learning, but really when we get to the case of what do you want to do, and we were talking about this last week, we had an offsite on Mountain View, like a lot of people just want to sprinkle machine learning on your product, on your solution, instead of understanding machine learning is really math and it's a prediction problem. So to your question, yes, we're seeing a lot of machine learning. We're seeing a lot of even Internet of Things. That's really also having a good leverage. And it's not only that, but we're also seeing a lot of big data analytics. So BigQuery is another product that's growing a lot. Not only in startups, but more on BigQuery is more on the enterprise side. Yes. So sure.
What kind of programs is Google doing for startups?
Yeah, actually.
I don't know if you've answered that already.
Yeah, I did, but don't worry. I can really summarize it. So yeah, we have a program for startups. Are you in Capital Factory?
Yes.
Yeah. Okay. Cool. The idea, if you've been in Capital Factory and there's some eligibility requirements, you can apply for being part of the GCP startup program. Okay. You're gonna have credits. So right now it's around $20,000 for a year. You're gonna have one-on-one support or office hours with architects from Google and support on the gold level support. You also have Google Apps accounts for 10 users free. So
great.
Sure.
Thank you, sir.
No worries. Anyway, so coming back to this, so yeah, security network, big data. Again, I kind of talk about this. So we started with a lot of things that today are hype, and we love this. Having this, putting it out on the open source ecosystem, and not like living it there, but also working on top of it. So MapReduce, and actually, sorry. Google File System eventually became Hadoop distributed file system, so HDFS. The MapReduce was our own part of research paper, and then we started. So at some point we started thinking, okay, what's next? We're good at batch kind of big data processing pipelines. What happens with the streaming processing pipelines? So at that point we have this Lambda architecture that says, you know what, you can solve both at the same time. So anyway, we started working, and now I'm gonna show you a little bit about this. But we have Dataflow. Dataflow is a unique, a unique programming model that allows developers to program, even if you want to do streaming or batch processing, big data processing pipelines. So again, we also put it out on the community, and that's, I don't know if you've heard about Apache Beam project. So that's part of, it's kind of the open source version of Dataflow. So anyway, I don't want to ramble into and go into the weeds on this, but yeah, big data is a big investment for us, machine learning also. And we're actually doing, I think I have a slide on this. Machine learning is not only a product for us. Machine learning for Google and the way we see it for the industry is a completely game changer. So just as a data point, currently we're optimizing the way we manage or the way we do maintenance to our data centers with machine learning. And that's just like something we publish. A lot of other things that we're doing internally. Kind of today, like the internal guideline for all engineers is you need to go and learn about machine learning. This is the next big thing. So yeah, this is big data. Openness. We've been investing about open source. We invest a lot in open source, as I told you. Kubernetes is the latest kind of really picking up. We know that there's a lot of container orchestration systems out there on the open source ecosystem. We, Red Hat, and Microsoft and other big players invested in Kubernetes. This is just, again, an example. But really what we want to send out the message is today and future's world, on the cloud world, is not going to be a single vendor cloud. We truly believe about having this multi-cloud ecosystem, even hybrid with on-premises solutions and cloud solutions. And we don't want startups, developers, and companies to be locked into us just because, I mean, it's Google. It should be easy to go away and start using another technology. And from a performance perspective, yes, everything is purpose-built for the cloud. From the beginning, it was being built like this. A very easy example, just starting and spinning up a VM, like a traditional VM. I'm not talking about containers, but traditional VM, like in any other cloud, it can take around 1-2 minutes. On our side, we're aiming to have 30-45 second maximum spinning up time for VMs. So again, that's just an example, but we have different examples on this, different data points that we really want to optimize regarding reliability, regarding speed, and regarding of the efficiency. Talking about price, because I know you asked me about this, we don't want to lock you in complex contracts. So we don't want you to start bidding for instances. The way we see it is, if you use it enough, you're going to have a better price. It's just economies of scale. So yeah, we want to pass you through that economy of scale. And the way that we have baked in our model is you're entitled to have sustained use discounts just by using it over some hours. So I don't remember how many hours, but this is a good graphic. So if you have your workload on GCE, talking about VMs, you're going to optimize it just by being on GCE. You're going to have auto scaling up and down. So you're going to be able to optimize your own architecture. Then even on the list price differences, sorry, we're going to be cheaper on the price. So you have another data point there. And then because of the sustained use discounts, you're going to have extra discounts. So this is a Gartner study. We're talking about 59 savings, up to 59 savings on the cost. More than this, I think this is a better way to put it. When I start talking with customers about pricing, and when a customer says, you know what, you're more expensive than any other competition, the way I like to put it out there is, you know what, if we're more expensive than what you're paying or that you will project it to pay, it's because it's a bug. So that's the way we see it. I mean, if you're overpaying us, it's a bug and we need to fix it. So, I mean, I think the message I want to get out there is pricing is just one thing here. Anyway, let me get just fast in here. I want to get more technical here. Another differences here, live migration. Google is the only cloud vendor out there that does live migration. What does this mean? You're not going to receive an email. You're going to receive a notification saying you need to take care of your workload because we need to migrate your VMs to a new or to a upgraded platform on Google. So you're not going to have that. What happens within Google is that automatically we do this. I mean, obviously we need to upgrade and we need to change your data to another server, to another data center, not data center, but to another server. But we take care of that. You don't have to do anything. So what happens here is we have live migration. You are being taken the data to another server, to another set of servers, and neither you as administrating this or your users are going to noticing this. So live migration means less downtime and more reliability. Another thing is we have custom machine types. What does this mean? We don't want you to think on your workloads, on your needs, based on what the vendor wants. What the vendor has on the menu. So what does this mean? You can always, and it's as easy as a slider. If you have on the UI, also on the API, you can have how many cores you want to have, how many RAM do you want to have on your VM. It's not a matter of I only have this 8 options, only 12 options. You can just play with it. So we have custom machines. If you have proven a machine that's going to be more efficient with a specific configuration, you can always put it like that in Google without tweaking it or anything. Another thing from the price perspective is the per minute billing. What does that mean? After 10 minutes, the first hour, we're going to only charge per minute. We're not going to charge the full hour. We believe that's the right thing to do because it's not a way of, you shouldn't pay for a full hour if you're not using the full hour for compute within the VM. And sustained use discount, as I told you. This is relatively new. Currently, customers or developers can resize the disk and there's no downtime. So if you have a disk within your VM on the cloud that's, 100 gigabytes and you need to upgrade it to 200 gigabytes, you just can go into your console and just increase this and you're gonna have your disk resized and you don't have to do anything else on the persistent disk side.
And that was for Compute Engine?
Yeah, this is for Compute Engine. Yeah. So from the multi-cloud world, this is actually, I don't know, has anybody heard about Stackdriver before? This is a company we acquired and we have been integrating into our portfolio. It's called Stackdriver. And basically what it does is a monitoring and logging tool for the cloud, but not only for Google Cloud, but from within this tool you can monitor AWS, you can monitor Azure, you can even monitor on-premises systems. And you have a ton, you have lots of metrics that you can really start monitoring on this side. So you can have extra visibility of what's really happening. Where's your bottleneck maybe? Is it really a memory thing? Is it really a bandwidth thing? I have, maybe depending on time, we have some demos around this. But this is a very good product, but also from a messaging perspective, it's something that really supports you having a multi-cloud strategy for whatever workload you want. I talk a lot about Kubernetes, but yeah, it's also supported in AWS and Azure, so I'm gonna run through this. And everything is open source. Everything is an API, so we don't want you to be locked into this. I'm gonna show you some demos on machine learning, but basically, yes, everything is an API, and we are publishing a lot of this. We are working with a lot of other vendors, which will believe in open source to move this forward into the open source technology. So one final use case, and then I think I'm gonna go into the demo. It's this Lloyd's Banking Group. This is a customer that their pain was to have a big data pipeline, and they were using traditional infrastructure for crunching all this data and getting answers to business questions. So what they had is actually they had a Hadoop ecosystem on top of it. They have Hadoop, they have Spark, they have the whole ecosystem, Big Hive. And here it says, 96 hours was the average time for them to get an answer to their questions. I remember being on a bank, it was in Latin America, and I remember they have a data warehouse team, and I remember talking with the CIO, and this guy was, he was like presenting of the team, and I remember this guy joking, hey, here's the data analytics team, also known as the origami team. And the reason they call him like that, and so why is the origami team like? Yeah, the reason we call him like that is because once they receive the request from the business, from marketing, from sales, from any kind of department, they craft the SQL. They know how to do it, and they just run it. But since they have to wait so much time for the answer to come back, they just start doing origami. So, and that's, again, this is the first wave, second wave. But so we jump in with them, we did a POC with them, we did a complete pilot. And with them, here's like the answer that you're seeing. We didn't only stop on the crunching of the big data. So we built some reports with them, we built some dashboards, having all this historic but also streaming information for it was a financial case. But we also start applying some machine learning models on top of this. So it's not only about seeing what happened through the rear view mirror, but trying to predict what's going to happen next. So if we apply machine learning to this customers on this segment of my bank, how really prone are them to leave the bank? So we're talking about churn, or how prone are they to receive a new credit card? All these kind of things we start applying some machine learning with them. Spotify. Has anyone seen this use case or this customer? This is also very neat because they were fully into Apache Hadoop ecosystem. They actually were using everything, even the bus for the Hadoop. They were using it. I don't want to spend too much time because I don't want to get you bored. So let me get into some demos here. Any questions so far?
Yeah, one question.
Yeah.
I'm sorry if you covered this already. So you're talking about the Google Cloud Enterprise. This is different than the App Engine, right?
It's App Engine is part of the Google Cloud. Yeah.
Okay.
Yeah. And don't worry, we haven't covered that much. Actually, this is the one I want to cover. To your point, have you used App Engine?
I've tried, yeah, but to be honest, I like to be able to log in and add the libraries I need and work on an actual console and not just ship it and hope it works kind of thing.
Yeah. Yeah, and I think that serves me as a segue. I'm sure it's kind of slow, but that's kind of like where you have this continuum here. You have full control on the left, virtualized hardware. I mean, this is what you usually are accustomed. Like, this is my machine. I don't know if you've heard about the pets versus cattle. I even name it. This is the server Andromeda. I mean, this is the kind of thing. I have control of this. And then, yes, cattle is on the App Engine. I don't care if they got killed. I mean, the instance is going to get up, it's going to get down, it's going to get killed, so I don't care about this. Yes, I mean, to your point, yes, with App Engine and with any platform as a service, you lose control because you are fully investing, and this is the way to go. And I'm winning a lot of things with this, but I'm losing kind of control, and I get your point. And actually what we're doing right now is, so that's why we have this kind of middle ground with Container Engine, with Docker, Kubernetes, where you have that kind of, you also have control about what's happening, but you can add libraries, you can add all the dependencies on top of it. Have you tried containers? Containerization?
What's it called?
Containers, like the containers strategy, Docker, or any kind of container? No?
No.
Yeah, maybe, we don't have a demo here, but I can show you something.
And does it auto scale on its own? Like
Yes.
App Engine does?
Yes, it does.
Does Compute Engine auto scale?
Yeah. So it has a feature called Manage Instance Groups. So when you have a single VM, it doesn't. But when you start like architecting on the cloud, so you can have groups, and you can have like pods of VMs, and you can define your metrics, so you can scale up and down depending on some metrics. So depending if you have some CPU, like if you get into the throughput of the CPU, yes, you can now scale. So so slow. Yeah. So this is kind of the portfolio I want to show you. I'm going to show you some demos. I want to leave some time for questions. So on the computer, we have App Engine, Compute Engine, and Container Engine. That's kind of like whatever kind of compute needs you have, we got you covered with this. On the storage, depending on what you want to store. So if you want just to store block devices, block storage, like I just want to throw out a video, I just want to throw out any kind of data, not database, but any kind of non-structured data, you can put it on the cloud storage. You have unlimited storage there. It's just like an API also, you can query it. So yeah, this is kind of storage. Actually, I have a slide for this. Then you have the SQL needs, like the SQL databases. So right now we have Cloud SQL. Cloud SQL is an implementation of MySQL on the cloud. We're working with other variations of other databases on the open source world to have also those flavors on the cloud, those distributions. And then we go into the NoSQL world, So if you have not only SQL databases, you have columnar databases, no key value relationships. So you have Cloud Data Store, you have Bigtable. So those are different type of databases, but I also want you to know they're there. And from the big data perspective, we also have a full array of services. Actually, let me jump here. Sorry, because I'm jumping so much, but I think this is going to be easier. So yeah, for storage, I think this is going to help you kind of map a little bit better this. So on the blob side, we have cloud storage. So any kind of binary data you want to just throw out there, you can put it there. We have several flavors or service layers on top of cloud storage. So if you have hot storage, it all depends on how fast you want to retrieve the first data and what kind of throughput you want to have. So we have like your traditional Google Cloud Storage, but we also have cold and warm storage solutions. Obviously, it's going to have a lower price point, and it's going to have some. You're going to sacrifice some times to get to the data, but for some use cases, it's completely worth it. And we're still in the matter of milliseconds of getting to the first data. So yes, we're seeing a lot of traction in this on companies that really want to get rid of the data problem, tapes, all that's kind of backup, and you just put it here. Then we have the NoSQL databases. So data store, it really started with App Engine. I don't know if you've heard about this, but it was the persistence layer for App Engine. So when you started working on an App Engine or developing an App Engine application, you could also have your SQL. You could connect to a traditional database, but you would start thinking on NoSQL. So instead of thinking about tables, instead of thinking about rows, you would start thinking about entities and kinds. So that was the way it was born. An App Engine, you're going to see the most type of users on this. But now it's separate services. What does this mean? Even Pokemon Go. So now with all this heat on viral of Pokemon Go, they're even saving the scores on data store. So that's the way that all of your store of your Pokemon user is going to be on a data store entity. And Cloud Bigtable, we have this for another kind of use cases, more on the ad tech side, when you really have to have consistency, you're going to have it here. And Cloud SQL, again, for traditional kind of architecture, we have your traditional RDBMS on the cloud. On the big data, and I don't want to get you lost because this is a lot of hexagons here on this. This is actually a test we have. We need to, I'm kidding, but it would be a good test to try to map what this logo means with a name. But yes, there's a lot of products on top of this. The best way to understand more than the products is when we start thinking about architectures and when we start thinking about use cases. So I want to walk you through a couple of this. So in the big data kind of world, we have BigQuery. BigQuery is an enterprise data warehouse on the cloud, fully managed service. So you don't have to think about how many VMs do I need to spin up just to start analyzing, 20 terabytes of data. So that's BigQuery I'm going to show you later. PubSub is it's a middleware on the cloud that really allows to have this real-time messaging. So think that we have an IoT kind of scenario. You have millions of devices just sending signals, sending information, events. How are you going to handle all this throughput? You can have PubSub. The easy way to understand about PubSub is just having this, I don't know if you were on the SOA kind of era. We have this enterprise service bus. We have it on the cloud. That's kind of the way. I'm not saying this is it, but you have this triggering of events, and you can transform them, and then you can pass it through the big data processing pipeline. And then we have Dataflow. So Dataflow, what it is, it's really, again, I talked briefly about this, but Dataflow, it's not like it is a product, but its strength, it's more on the programming language. It's kind of magic. So you start programming, you just import some classes, you just import, depending on the language, you just import something, and then within the code of your application, you can start doing streaming and batching processing of your events. So you can start doing all the ETL within the code of your application, and that's how you do Dataflow. It's a fully managed service. You don't need to think how many VMs do I need, how many RAM, how many cores, and nothing like this. You're just gonna have this within the code, and obviously within the service that's running in Google. Yep.
Is it possible to access the data directly from the user's browser? Like let's say you had a JavaScript app.
Yeah.
Running in the browser, could it store data right into the cloud from there?
I think it depends on your architecture. Obviously, there's a privacy thing. I don't know.
You would probably send that data to something.
Yes.
Something needs to
capture it.
Set that data and
Yeah.
process it, so maybe you have App Engine, an application running in App Engine that ingests that data, and then it might pass it on to a message queue, which would be based on PubSub, or maybe send it to Dataflow to do some additional processing and dump it into BigQuery or something like that to do analytics on. So,
Yeah, and one of the things I've seen is like depending on the browser, some of them so have Chrome extensions if you're using Chrome, but at the end it's an App Engine, so something needs to capture it and ingest it. But yes, you could do it.
or it could be your app running in traditional VMs in the cloud, whatever it is, or containers or something like that.
Okay.
So yeah. A lot of different ways this can happen. So.
Yeah. So anyway, let me show you. Has anyone of you seen BigQuery before? No? Cool. Let me show you something here. Yeah. So this is the one-on-one query. Demo of BigQuery. So what's BigQuery? BigQuery is an implementation of a problem of technology we have in Google. It's called Dremel. And Dremel was born, again, from a Google problem, big data problem. Actually, this is kind of geek, but it's like we needed to know what were the servers that were failing from the operation side from our data centers. And for that, you can imagine that there's millions of servers, there's millions of services too. And so one of the people of the ops team said, it should be as easy as just running an SQL statement and just being returned what are the servers that are being underperforming right now. So again, this is distributed technology. This is completely different than anything else out in the market. There's no competition to BigQuery, and I'm going to show you why. This is, again, I'm just using a console. I can use it as a console, but you can use it to feed any kind of application. You can have an API for this. And here in BigQuery, what I have, actually I'm going to compose a query. What I'm going to do here, so what I'm going to do here, and again, this is the one-on-one on demo on BigQuery. Sorry for this. What I want to do here is we have a data set that actually is a copy of Wikipedia. And from Wikipedia, I want just to query some stuff on that data set. And it's not going to be that big. So here I have the query. I just want to show you how it is. And again, this is just a statement. But what I'm going to do here is I'm gonna go through that database. One key thing on BigQuery is that it's denormalized. So it's completely different, like the schema that I want to put in here. It's just gonna be a large wide table. And I don't need to think about strategies about how to optimize my query. That's a good thing about this. It's gonna have a distributed leaf to get into this. And here I have my Wikipedia statement, so I might have my select regular expression from where, and I'm gonna run it. This was cached, so I'm cheating here. So the reason I run it again is because the results were already cached. So here, what I did here, it just got to a data set. It only had 1 million of articles in Wikipedia, and I just run this query to, again, I'm going to show you this query again. This query, what this query is doing. So here, what I'm doing is just running some regular expressions. I could run some joins. I could run some SQL statements within it to transform, not to transform the data, but to really get the answer that I want to get here. And here, what I'm trying to see is, from this 1 million articles, how many ones got the highest views with this regular expression. So it's like it tries to resemble Google, but it's not only talking about Google. So here, I'm getting Golden Glove, I'm getting Gramophone, but again, this is a small subset. What really magic around here is, I don't want now to go to data set about 1 million, I want to hit the 1 billion data set. So imagine I have 1 billion articles here, and I want to do the same question, and here's running. It's taking a little bit longer, but I think the point here is it's not going to be, it's not going to take like linear the time just to run through this query. So here, I do have better information. So here, instead of having this 56 megabytes, I have 56 gigabytes. And here, then I have like, okay, Google was one of this. It wasn't on the previous data set, but I have 807,000 views for this. This doesn't say too much. Let me get to a better use case here. So one of the use case I want to show you here is more on public data sets. So, and again, this is a good tip, even for startups or whatever use case, even for just onboarding on the technology. There are different use cases from the public data set. So the US government publishes a lot of these data sets. You can have, and here I'm going to show you one of the New York City data set. They just published, several weeks ago, they published what are the public rights on the taxi companies. So I can get into this. The weather is a huge one. So if you want to correlate some event that you have on your company or on your application with, I don't know, rains or snows or alerts, this is a terrific use case for BigQuery. One of the POCs that we run on a customer was, they were a retail company and they wanted to understand what kind of correlation they have when they were stocking some products and why they run out of stock or they have too many items in stock, depending on some events. So they did this with BigQuery and they started correlating this kind of events. So here, this is precisely the case I want to show you here. I want to show you the case where I have taxes. Sorry. Yeah, here it is. So this is a very basic, should we see, query. I'm just saying, you know what? Let me get you a data set because you're not seeing nothing here. So I have the data set here, and I'm saying from this data set, New York City TLC, I want to see the yellow trips. So I have here this table. If I go here, let me show this to you. It's kind of funky today. I want to show you the data set. Here it is. So this is the data set. Again, this was public, so it doesn't. You could access to this, and actually there's some tutorials around this. The schema, you have it. I mean, you would think of it as a database, but it's a different schema here. And the description, it's 130 gigabytes that we're going to query here. And if I want to see and go and see the actual data, I can do it. So I can see it here as a table, but everything is JSON format. So I can have it here in case that you want just to have and access the information from here. And again, I'm not having here the results, but I have the data set itself. So let me run it again.
How did you import that data?
This was already, so that's a good question. Google has published this, like this data set was already there. So Google publishes, you just put the URL. On your specific use case, we have APIs, so you can import the data. This can go through Google Cloud Storage. This can go through any kind of API on the ingestion part. You could just start like using the streaming API and put it on BigQuery as tables. So anyway, this is kind of lame, the demo, but you would see here the different trips. What I want to show you here is from this huge 130 gigabyte data set. I'm running a query. I'm doing 8 gigabytes, 9 gigabytes, and it's taking less than 4 seconds. I know this is just okay. Yes, it's running a little bit faster. What really gets us into the door of big deals is when I want just to connect this with what Lloyd's did. Lloyd's with a similar use case, obviously more complex queries, they were running and they were taking 96 hours. So more to the ground use cases here. We're seeing a lot of companies having, so let me get to the gaming kind of use case. On the gaming side, you have all this information. You could have it on your App Engine logs. You could have it on a different database. You could have all this information and you start correlating it. You put it here. And then you would start asking some business questions. How many users are getting killed on level 12? what's the villain that's killing the most users and that's being the most hated. And this is the kind of things with BigQuery that you can really answer in a matter of seconds and can start taking A/B testing and stuff. Yeah.
Is this like a front end to your SQL product, or is it a separate database?
It's a data warehouse. I mean, it uses SQL actually from our latest announcement last week. We're now supporting SQL standard, but it's not an SQL product. I mean, it's not an RDBMS. It's not a relational database. But yes, I mean, as you can see, we're writing SQL statements.
So don't think of it like a traditional database.
Yeah.
Think of it more of an analytics data warehouse where you have all this data sitting that is just data. It's not information until you craft your query and turn it into information that you can act on. And the big thing is, the reason it's so fast is you're leveraging all the machines Google has to run these queries. So you're not spinning up 5 VMs to run this. No, you're leveraging Google's entire infrastructure to take that normalized data and get something useful out of it with very, very, very large data sets.
So if you're building a new app, is this the product that, the database that Google recommends?
No, this is for the big data analytics. So if you're building a new app, I would go back to the storage part, depending on what kind of schema, what kind of architecture you want. I mean, if you're building a new app and you would like, I mean, you're just like a CRM, traditional CRM, or you want like an SQL database, we have Google Cloud SQL. That would be one option. If you have no SQL kind of information or data, you would have data store and Bigtable and different kind of database. But this is not for building the app. This is more for the big data analytics parts of the app.
This is for reporting after the app is out there. You want to figure out some business questions such as, why are so many players dying on level 12? This is where you can input that data, run your query, get an answer on it, and then act on that answer.
Yeah. And again, this gets connected, just to kind of close the loop, this gets connected to dashboard solutions. So what we see it a lot is that it feeds dashboard reporting solutions like Tableau or BIM or ClickView. That's what I want to show you here. And we actually have our own solution. Oh, sorry, this was for a customer. Yeah, but this is a reporting solution built from Google. This one is the Google one built by Google. And here you're actually connecting. So this is where you get the business user in front of the BigQuery. I mean, you wouldn't put a BigQuery, or I'm sorry, business user here. I mean, this is just ugly and doesn't mean anything. But once you have this capability of building a dashboard and getting this real time, because this is real time. I mean, if you're ingesting data in real time, you would see this refreshing constantly. So here I have different kind of, if I go and edit this dashboard, I can have a different kind of charts and plots and whatever. I have it here. So I don't know if this answers more of the question. Yeah.
Yeah. So typically, to get a dashboard like this, would you be downloading a copy of the data, or would?
It's the data. It's
okay.
It's the
actual
same
data.
Yeah, you don't have to
Okay.
download anything. It's live data that you're getting there.
And that's the big fundamental change for businesses, is suddenly you have something that used to take 96 hours to get an answer from. Now you can get it in minutes, update your dashboards, give it to the upper execs and say, hey, look, this is what we discovered because of this, and we need to make this change. So that's where the real power that comes into play.
Cool. And I just want to show you like cooler demos here on the machine learning, because this is getting a lot of traction. So what happened with machine learning? Just really quick. We have the full spectrum. Has anyone here heard about TensorFlow? No? A couple of you? Okay.
You mean temperature flow?
I'm sorry?
You mean temperature flow?
No, TensorFlow, like the neural net machine learning. No?
No, I had a physics background, so we use tensors, but we call them something else. I don't know if it has the same name.
The name comes from.
Yeah, it comes from there. Yeah. So anyway, like just to show here, like machine learning and prediction is not new. It's something that has been there like for a long time, and the algorithms itself haven't changed that much. But what really has changed right now is like, okay, the compute power that we have with cloud, and also, I mean, how can we make it accessible for developers? How can we make it accessible for data scientists and all this kind of stuff? So the machine learning, and this is like a 2-hour, 3-hour presentation, but machine learning has different phases. One of them is the training phase. I mean, you just can't apply and think, okay, I'm going to sprinkle machine learning, and okay, this is going to be magically, and just suddenly the computer is going to know and predict better results. So you would have the training phase, and depending on historical results. But that's kind of the one end of the scale here. The other end is, you know what, I don't want to start training my models. I just want to connect to something, to the API that Google is giving me, and I want to start getting results from my own application. So I think the best example here that's really gonna get us closer is Google Photos. Have you used Google Photos, like the app, before? Yeah. If you have, and if you haven't, you can try to download it. It's a very good one because you always have your backup there for free and for life. But anyway, if you type in there like Paris or Austin or any kind of word or faces, you're gonna get this. And what this is using is the image recognition API that we call Vision API. That's one of the APIs that we have. We have a lot of startups connecting to this. I was just talking in the morning with a startup that they are having, so the receipts that they have, they are just putting them in batch. So they have thousands and thousands of receipts, and they're putting, they already taken pictures, and they want to do a lot of machine learning about it. So they want to start knowing, okay, from these receipts, how many of them were from this provider, and how many of them would have this word. So that's one of the things that they're doing. So instead of me talking that much, I want to show you the demo on this one. So yeah, while this loads, Vision API is one, Speech API is another one. So Speech API is, I wanted to do speech to text. So if I have a video, so think about YouTube. I mean, if you have YouTube and you're using YouTube videos, and you click in the closed caption service, it's gonna have like automatically transcribe the voice or the audio. That's the goal of having the Speech API. So this is an application built on top of Vision API. This is, I mean, it's using the API. That's a good thing about having an API. You just can connect anything. Here we have almost 100,000 images here. So what this is doing is just doing a tag cloud of words and terms that it recognized based on this batch analysis of all these images. So I can start navigating here. I can, you know what, I want to go and see photos about houses, or I want to go see photos and pictures about plants, or whatever. So all this nodes and all these graphs that you're seeing here are built dynamically based on this information that it's extracting from the images. I have here some pre-canned images. So just for you to see what kind of labels I can get out of here. So if I got here, I mean, this is a cat, it's the internet, so I have cats. And here you have some labels and you have some scores that Vision API is getting from these images. So it's almost certain that it's a cat. I mean, it's almost for sure. And it's almost certain that it's a pet because it's this type of cat. And then it also starts saying what kind of breed it is. It's vertebrate, I mean, all these kind of things. The color, so it's also giving me a palette around the color. And I mean, I'm putting it here pretty on the application, but this is API. So if I want to go and see the JSON file, I have it all here. So this is what is allowing me to build the result that I'm seeing here. Again, if I want to see on the graphical part, I have it here. Some interesting use cases, again, that companies are using is, I want us to validate and vet that this is not an adult picture. So here you can see the score here, the adult it's good, so we don't have that. No medical, no violence, but it can be a spoof image on this one. So anyway, this would be the first image. Another kind of use case that we see around Vision API is I want to extract text from the images. So I have this image that I take somewhere else, and again, going back to the Google Photos, if you have a picture that you take, I used to take pictures of my receipts with my cell phone. If I go there and put the name of the restaurant, it will show me the picture there. So here, again, it's showing me, you know what, this is a sign of a road, traffic sign, it's yellow because I'm seeing it, but it extracted the text. So that it was like a tree, kangaroos crossing next 2 kilometers. And the color and also the other labels here. What happens, another use case, what happens if I want to see, or for this API to detect me automatically a landmark of a specific, specific place. Here, I mean, I'm not American, so I wouldn't know what kind of field this is. You would know. I know it's a stadium, baseball stadium. So yeah, this is what it's saying. It's a stadium, team sport, ball game. And the text is actually extracting from this different kind of text on the same picture. So Geico should be here, Toyota, Pepsi Cola, whatever. But then it's saying, you know, I want to see if it's, it's a landmark. and it's actually taking the coordinates of the metadata of the picture, and it's saying it's the Citi Field Stadium. So I can have it here, and I can go to Google Maps and show me where this picture was taken. So it's a New York Stadium. Again, this is all the JSON, and I have it here in case I want to reuse it. And the final one I want to show you, because this is a big use case of Vision API, it's also the face recognition. But not only saying, yes, this is a face, but really trying to understand emotions from the faces. So here, I have a picture. This looks like a school something, or some kind of festival. And if I go to the graphical part, it's going to say the same thing about the image itself, custom, social group, whatever. And the text, it's trying to pull something here. You could discard it because it's not saying too much. But then it's saying something about the people itself. So I can try to recognize. So person 1 is going to be here, and it's going to start scoring what's the joy emotion here. So yellow, yes, not everybody's happy here. But if I go to person 2, which is here, it's actually showing me the number. This person is more happy, is more joyful than the rest of the person. So I can see this, and I can see other metadata here that's being extracted by Vision API. So the person 2 has an angle on his face, whatever. This is all getting extracted in a matter of minutes. So again, this is just kind of like an example. This is just one API. We have speech API. We have several other APIs. But I don't know. I thought it was kind of cool because again, it's already built. It's just an API. You just can connect it to whatever application you have, and it's going to start showing like results. I don't know if you have questions about this. If you want to try it, again, like with any other of Google products, you will have a free tier. So you just can go on Google Vision API, and you have the free tier. And after you get to that free tier, there's going to be a pricing for it. But it's very good pricing comparatively. And I talk about Google Speech API, Natural Language API is another one that's being used heavily. One use case I can share. What happened? I have a call center. A call center is a very good example because I have the speech API. So I have a speech API from the voice calls. I take that and I just translate it and transcribe it to text. And from the text, I can start doing Google Cloud Natural Language API. So what does this mean? Let me show you one really quick. It's so slow. Now basically what it's going to do is it's going to do entity recognition of the text. It's not only for English, but also for other languages. Right now it's English, Spanish, and Japanese. Sure, I think I have it here. Yeah. So this is the easy ways to demo. So let me, I don't know if you're seeing this. So what I'm going to do here, I'm just going to copy a text of a news, really close. And let's see if this is something good, something bad, what kind of information it can take from here. So let's talk about the Austin Startup Week. This is a news on Sunday. And I can take this and just paste it here. And let's analyze this. And it was just like this. And what it did here, I think this is pretty cool. The way that we parse every word, it's actually applying machine learning algorithm on the natural language API. So this is also using the Translate API for the algorithm to know what's the preposition. So doing all this grammar analysis, it's not easy. But what we have done is taken the algorithm and the model so far away that we can know which one is the object, which one is the subject, etc., etc. So we have here like a visual way to see this. And if we want to see like the entities that it recognizes, let's say Austin Startup Week is an event. It's not a person, it's an event. But Jacqueline Hughes is a person, Joshua, it's a person, etc., etc. So you're going to start seeing different labels within the, this is so far away, sorry.
What's this called?
Google Cloud Natural Language API.
Okay. What languages do you support?
Right now it's English, Spanish, and Japanese. I'm sorry, programmable, okay. This is an API, so you could connect it to anything. Yeah, okay. It's a RESTful JSON API.
The big thing to take away with machine learning is that these APIs, the Vision API, the Natural Language API, they have been trained by Google already, and they're continually trained. In order to take advantage of machine learning, you have to have the data to train your model. If you don't have that, you don't have anything. And getting the data to train it is the hardest part. That's what takes the most time. And then actually building the model is relatively straightforward, given the complexity of everything behind the scenes. But the data is the most important piece to get accurate output from all the machine learning technology out there. So,
So does this excel at turning text into speech that sounds like a real person?
It's more the other way, speech into text. Yeah, we don't have a, I mean, we do have, but it's not part of the Google Cloud, like text into speech. Yeah, I know there's.
I mean, there's a lot of stuff out there
Yeah.
that does it, but doesn't, usually sounds kind of robotic.
Yeah, that's not like part of the offering. Yeah, I'm not aware that we're building something around that. Yeah, I agree with you.
There'd be a
It
lot
sounds
of demand
robotic.
for that.
Yeah.
but using something like TensorFlow, which is the open source cloud ML technology, you could build that yourself if you were starting or something like that. So, and I don't know if the other companies that already have a stake in that market are using something like that to make their products better. They could. So.
Yeah. So yeah, we're getting to the mark of the hour. The last thing I want to share with you, and again, thanks for staying and just seeing this demo. It was very difficult just to understand what to do. I was talking with James earlier. I mean, should we do like a different kind of scenario, like a demo end to end? I think it could have been better, on the sense that you would understand, like end to end, what are we trying to propose? I'm trying to build something like that, but I decided like to show you kind of the highlights of BigQuery, which is very important, and all this machine learning APIs. But one of the things I told you, we were last week on an event on San Francisco. It's so bad this. I can talk this. One of the things that we just announced is that we are launching a Google certification program. So it's not the traditional only cloud architect program. Like, okay, yes, we have this. I mean, if you're a Google Cloud Architect certified professional, you will know how to spin up instances. You will know how to autoscale. You will know how to put like network balancers, et cetera, et cetera. I mean, that's something that it's obviously a very well-deserved and needed skill needed for the future. But really what we want to do different is on the data part. So we are, and this is not the only certifications we're going to have, but this are the ones that we announced. We're also going to have a Google Data Engineer certification program next year. And this is more on the machine learning, data processing pipelines, I mean, that kind of stuff. I mean, how can you start doing it into this? So with that, I mean, I just want to leave some space for questions if you have. And thanks again. Yeah?
The APIs, do they run in the cloud itself? They run in the cloud, right?
Yes.
So, and like typically, like if I want to process maybe 10 images, and if I feed in 10 images, what will be the processing time?
What will be the processing time?
Like I want to feed in like 10 images, and
Yeah.
then I want to see the outputs from the API. So what will be the processing time, the results?
Yeah, it's super fast. I mean, I know that's not the technical answer, but I've been trying it. I mean, it's a matter of milliseconds. The one that you have, like here, we have 100,000, like on a batch.
So
yes.
Just go and
Yeah.
infer the image. And
Yeah, I mean, it is milliseconds the response time. If you have a low set of images, like 1, 2 images, actually, I think there's a public demo. That's on the webpage, right?
I think you can leverage it beyond.
Yeah.
It's a difficult question to answer. It depends on how many people are using the system at that exact moment.
Yeah.
I don't know if the size of your image matters. I mean, it may take a while to upload those images to the actual service to do its processing. But yeah, it shouldn't take long.
Yeah, and that's a good point. The one James right. I'm talking about like this self-service case. Like I just uploaded and just say Google, okay, give me the labels and the score for this. You can do it here on the page, and it's public. But yeah, on the architecture, it's like there's so many different factors to weigh in. Yeah.
So would you say your processes, would they become IO bound first or compute bound first?
For this particular service?
Or just in general?
Well,
I mean, I guess for the service, let's start with this service.
I mean, all you have at your fingertips here is the API. Like even if you sign up for a Google Cloud Platform account, you can go click this particular API, and that's your only way into it. So you don't deal with any of that stuff.
Yeah.
So like those are questions like we can't answer because we don't have visibility to the back end of the system.
It's really an answer like, I mean, you shouldn't care, to be quite honest, because this is the realization of fully managed service. You shouldn't need to worry about that. It's only an API, and you're going to be, I mean, Google's going to take care of this. On different workloads, yeah, you're gonna have compute intensive, you're gonna have memory intensive workloads, but for this, you shouldn't care.
Sorry, so I mean, are you charging by the I/O operations or the memory operations?
On this,
Or just the flat out time it takes to run, or what?
it's charging on the image. I mean, how many images are you going to analyze?
There should be pricing on this page
Yeah.
somewhere.
And the
There
image
you go,
size
there.
doesn't matter?
Yeah, so here you go, so, let's see,
Yeah, here it is. Oops, sorry.
Does the image size matter?
let's
No, it
see.
shouldn't. It shouldn't. It's more the unit size.
So I can slap all my images together?
Yeah, but you wouldn't have good results. I mean, if you just like stitch them together.
I was thinking, Joker, but.
Okay, so yeah. I mean, I think there's a limit on the size, but not on the pricing. Like, we're not gonna price you different, but there's a limit. I don't know how much is it, but yeah, it's more of the.
And so, I mean, I can define my own filtering functions, or they're built-in filtering?
So with these, you cannot. That's where you leverage the software called TensorFlow, where you can do whatever you want. And you can make your own models. Like there's a company that has a whole bunch of cucumber farms, and they want to figure out, based on images of the plots of land where the cucumbers are grown, what ones are rotten, what ones are not ripe yet, or however that works. And they built their own model to figure that out using TensorFlow.
I thought it was an April's Fool, but it's real. it's
They have to train the model.
Yeah, that's the important part, is they have to go out and get their own pictures of what's a cucumber. Like, you have to train your model as to what is that thing, and then tell it, this is what a rotten looks like, this is what a fresh one looks like, or this is one that's halfway ripe, or whatever. You have to get all that data, and it's a lot of data to train it to get the accuracy that you need. So that's the hard part.
TensorFlow gives us the model itself, the algorithms, right? It has pre-built-in packaged algorithms that we can use.
Ricardo mentioned earlier that algorithms for, I'm no machine learning expert by any means, so keep that in mind. But the actual, I guess, generic machine learning algorithms have been around for like 30 years, and they haven't changed. So those, I think, are just built in, and that's what you build your model on top of to do whatever you're trying to do. So.
Well, that's it. Thank you very much.
So
yeah.
is the machine learning APIs, are they HIPAA compliant? So
Not
if I
at this
want to
moment.
send- What's that?
No, not at this moment. Machine learning. Yeah, we do have other services, and not at this moment. We can't share anymore. Yeah.
Yeah, that's actually a good question in general, because I know one of your competitors, they advertise that they have, you can get HIPAA compliant servers if you have a medical application.
Yeah.
So does that fit into Google Cloud at all, or talk to me later, or what?
Yeah, we're aware of the issue and of the business opportunity, if you will. So yeah, we're trying to work, but this is like Vision API. Some of the services are still in beta mode. So yeah, we're trying to work to have that.
There are other services that'll get the compliance before this will.
Yes.
So.
Other services that
Other
Google-
products within Google Cloud Platform that'll get it before that.
Okay.
I don't know what the roadmap looks like for this. So.
Yeah, no, I mean, not to drive the conversation here, but I remember reading a Wall Street Journal article, gosh, it must have been 5-10 years ago, that they were saying that the radiologists in America are so expensive, they take the image, they send it to India, and they get it analyzed, and they send it back the next day.
Yep. Yeah, I mean, that's definitely a use case that drives adoption of the product and extending the features of it, because, it's a perfect example.
Let's say we have a question like next year that we don't know what the question is, like who do we contact to get help?
Yeah. So I'll give you my email. But yeah. So yeah, we can work. I mean, that's why we're here. We work on Austin.
For like the year later question, almost every page has contact sales in the upper right. So that would be kind of your first entry. And then kind of the flippant answer is Google it first and see if you find it.
Right.
Typically you can. There's pretty extensive documentation. I mean, we use it on a day-to-day basis because things change so quickly and so much. We can't keep up just on our own. So we're constantly querying our own
So there's a different
documentation.
sales contact for each product?
No,
that's just
kind
the
of
general, like, talk to sales and then somehow it'll filter into us.
Okay.
So,
Yeah,
to answer like your year later question, like, if you want to get in contact with someone, so.
Yeah. And yeah, if you have like a question, like I will probably send you like to a Google page, but my email is RP. Actually, I'm gonna write it here in case you haven't, because I left my business cards. But yeah, I think that's a good point, and this is changing a lot, and will be changing more throughout this next year a lot. We're announcing a lot of things.
Other questions? Good, good. You wanna stick around too, we'll hang out.
Yeah.
After the